And chapter 5 is about discrete probability distribution. Probability distributions. Okay, what does that mean? Discrete probability distributions. Okay. Depending on the values a variable can take, the variable can be either continuous or discrete. Okay? So variables, according with the values it can take, it can be discrete or continuous. Okay. Discrete variables are those variables that can take values that are discrete or can have only a few values in a range. Okay? Like, how many children do you have? I mean, you can have 0 or 1 or 2. You cannot have 3.3 children, right? So those variables, discrete variables, are variables that can only take certain values. Okay, like the number of children, the number of gas stations that you find in a highway, the number of customers that arrive to your shop, and so on. So those are discrete variables. Continuous variables are those variables that can take any value in a range. And I think like time, distance, area, these are continuous variables. Time, I mean, how long did it take you to go from your house to your school? It takes you 1 hour, 1.2 hours, 1.3 hours, 35 minutes, 35.3 minutes, So those time is a continuous variable because it can take any value in a range. The distance, the same thing. How many miles do you travel? 1.3, 1.4, 1.345, whatever. And the area, what is the area? 2 square feet, 2.3 square feet, and so on. Okay? So those are basically the difference between discrete and continuous variables. Next chapter, we are going to cover continuous probability distribution. Okay? But in this chapter, we're going to cover discrete probability distribution. So those are variables that can only take specific values. Discrete. Okay, discrete. Probability distributions, what is that? Okay, we have variables, and the variables can take values. Okay? In this case, a few values. In discrete variables, a few values. And how those values and the probability of these values are distributed is what is called the discrete probability distributions. So I have 3 values for this variable, right? 1, 2, and 3, whatever variable it is. The variable can take randomly certain number of values, right? And what is this random issue? It based on probabilities. And the probabilities are going to give you the frequency in which that variable is going to take these different values. And this is the distribution of the probabilities for that random variable. Okay? When you, let's say this is a 0.3, 0.5, and this is 0.2. This is 0.3, 0.5, and 0.2. Let's say that this variable can take values 1, 2, and 3, and the values for 1 is 0.3, that's the probability, for 2 is 0.5, and for 3 is 0.2. This is the discrete probability distribution. Is the values the variable can take and the probabilities for each one of the values. What is important here is that the summation of all the probabilities has to be equal to 1, right? Because there are no other values that these variables can take. So basically that's what is a discrete probability distribution. It's how the probabilities are distributed for a random variable that can take different values, and these values are guide, okay, depending on probabilities. Okay, so usually what we have is x and p of x, this table. And in this case we have 1, 2, and 3, and the probabilities are 0.3, 0.5, and 0.2. When you add these values, it has to be equal to 1. Right? It's exactly the same. But that is a chart, this is a table. But it's exactly the same. Now, the mean or the mu is going to be equal to the summation of x p of x. That's it. That's the formula. Is the x value times the probability of that value. And I'm going to add all those numbers, and that is going to be the mean of that distribution. What is the mean of this distribution? Well, what you have to do is to have x times p of x. In this case is 0.3. In this case is 0.1. In this case is 0.6. Right? This is 1. This is 0.6. Okay? So it's 0.3 times 1 is 0.3, 0.5 times 2 is 1, 0.2 times 3 is 0.6, and if I add all those values, it's going to be 1.9. So this is the mean of the distribution of this particular distribution.
3 times what? How you got those numbers again?
Is you multiply x times pdx. You multiply the value of the x times the probability that the distribution gets this value, that the variable gets this value. So these are the probabilities, and these are the possible values. Can be any value. I mean, I put 1, 2, 3, but it can be any value. Okay? So the mean in this distribution is 1.9. Okay. What about the variance? The variance is a little bit more complex. The variance sigma squared is equal to the summation of x of I minus mu squared times p of x of I. There is a shortcut. Sometimes it's easier to use the shortcut. The summation of xy squared times p of xy minus mu squared. Any questions? Do you want to do the variance for this one? Yes.
These are all going to be like population data.
Huh?
These are all going to be dealing with population data. Like
Yes. I mean, because these are distributions. These are the whole variables. These are not data points. This is for the whole distribution. Like for example, if I roll a die, the distribution is this. 1, 2, 3, 4, 5, and 6. And the probabilities, all the probabilities are going to be 1/6. This is the probability distribution for rolling one die. No matter how many times you do it. So this is the distribution. This is the whole distribution. Every time that you roll a die, you're going to be guided by this distribution. What is the probability that each one of the values that the variable can take is going to take place? Depending on what? Depending on probabilities. But in the long run, if you roll a die like 6,000 times, you expect to have 1,001, 1,002, 1,003, and so on, because that is the expected. That's what you expect at the end, in the long run. Your book then talks about the expected monetary value. And the expected monetary value is nothing but the mean of your distribution. And I have one here. And it's interesting to see that because they talk about a company that built something. So if and they talk about the net profit and the probabilities that happen. So either you complete it before schedule. If you complete your project before schedule, you're going to have a profit of $120,000. If you complete it on schedule, you're going to earn $100,000. But if you complete your project after the due date, you're going to get only $90,000. Okay? And the probabilities are 0.25, 0.60, and 0.50. So this is a discrete probability distribution. So the variable is net profit, and the variable can take only three values: 120,000, 100,000, or 90,000. And the probabilities for this one, for this variable is 0.25, 0.6, and 0.15. Is this a valid probability distribution? Discrete probability distribution. Is it valid? The only way that you can know that it's valid is when all the probabilities add 1. Okay, in this case, they are 1. So this is a valid discrete probability distribution. What is the mean of this distribution? The mean is the expected value or the expected profit that I am going to make in the long run. Not today. Not in this case, not in this project, but in long run. If I repeat and repeat this construction again and again and again, let's say that we repeat it again and again and again, what is going to be the mean? Well, let's get the expected monetary value. And that is the mean. Is the mu. Expected monetary value of this project is the mu, and it's going to be the summation of x times p of x. And And it's going to be 120,000 times 0.25 plus 100,000 times 0.6 plus 90,000 times 0.50. And that is, I don't know, $120, huh?
30,000. Oh,
Okay. What is it? Someone did it? I got 103,500. That's what I got. Did I do something?
No, you didn't.
103,500. Yes. So I expect in the long run make $103,000 every time that I engage in this type of constructions. Okay? So sometimes I'm going to end earlier. Sometimes I'm going to end on time, and sometimes I'm going to end past the due date. But in the long run, this is the expected monetary value that I'm going to get every time that I engage in this project. Okay. Okay, your turn number 2 is pretty interesting. I mean, guys, part of the studying your chapters, you need to do your turn part on the book. Please do that. I mean, they are very, very good examples, and the answers are in the back of the chapter. Your best friend proposes a bet on the basketball court. You get to attempt one free throw. If you make the free throw, your friend will pay you $20. If you miss, you will pay him $25. So if you hit, you're gonna get 20. If you miss, you're going to lose 25, right? Based on your past performance on your court, your estimate of probability that you will make the free throw will be 65%. So for this one is 65% or 0.65 the probability. And that you miss what? 35, exactly. I mean, either you miss or you don't miss, or you hit the. I mean, you insist. Okay. So, should you take the bet? I mean, if you miss, you're gonna lose $25, but if you bet, you're gonna get $20. So in this case, you have to do the expected monetary value on this bet. And the expected monetary value is going to be the summation of x of I times p of x of I. Okay, what is x of I in each one of these? This is the x. And these are the probabilities. Okay? And this is a valid probability distribution because of what? Because if you add these numbers equal to 1. So what is the expected monetary value? It's going to be 20 times 0.65 plus negative 25 times 0.35. Okay? It's not plus positive 25, it's plus negative 25 because you're going to lose. I mean, you have to pay your friend $25. So it's 20 times 0.65 and 25 times 0.35. This is equal to 4.25. Is it right? Right?
Yeah.
Right? Someone did it? Okay. So I'm expecting that in the long run, I'm going to make $4.25 at the long every time that I make a throw. This is the expected monetary value. So shall I make the bet? Of course I should, because my expected monetary value is positive. Okay. What would be the answer if the probabilities would change? What would be the answer if should you accept the bet if, let's say, that you get $20 and the probabilities are 0.4 and the probabilities that you miss are going to be 0.6? Should you do the bet? Okay, expected monetary value in this case is equal to be 20 times 0.4 plus negative 25 times 0.6. What? Negative?
Negative
14? 14? Wow, 14.2. So it's a negative 14.2. So in the long run, you're going to lose $14.2 every time that you throw. So in this case, you shouldn't accept the bet. Okay. What? 7? Okay. Yeah, the 14 say, well, it's too much. Okay. 0.4.
I put 0.04.
Oh, okay. Don't worry. Okay, so it's a negative $7. So it's still, when you have this negative number, you shouldn't engage in this kind of betting.
How would you know how many shots you have until you stop going?
No, this is in a long run. Yeah, it's when you infinite. So this is the expected. So this is the mean of the distribution. So this is the expected value when you do this infinite number of times. Okay? Good. Now, in this chapter, there are 3 very important discrete probability distributions that we are going to cover. Binomial, Poisson, and hypergeometric. Hypergeometric. Okay, let's do binomial distribution. Okay, today we're going to cover binomial distribution. Binomial distribution is a distribution that is called binomial because of what? Because every time that I try something, either you have 2 possible outcomes, success and failure. Okay? You have 2 possible outcomes in each step of the experiment, either success or failure, and or can be good or bad, approved, not approved, passed, not passed. I mean, whatever you may want to call it. Defective, non-defective, whatever you want to call it, but it has 2 outcomes, and that is why binomial distribution. You have 2 outcomes. Each of these steps are independent from each other, and every time that you have this experiment, you can have success or failure, and the probability for success is P, and the probability of failure is what? You have two outcomes. The probability of success is P. What is the probability of failure?
1 minus B.
1 minus P. And that is going to be called Q. So if I succeed, if my probability of success is 0.3, what is the probability of failure? 0.3? 0.7? 0.4? 0.6? 0.5? 0.5? And so on. So this binomial is a multi-step experiment, and every step is independent from the other, and in every step we can have two possible outcomes, success or failure. The probability of success in each one of these steps is going to be always P, and the probability of failure is going to be always Q, or 1 minus P. And we are interested in the number of successes in n tries. Okay, so that's what we want to count, or to know what is the probability. Number of successes in n trials. Okay? So we have this n-step experiment. And we have, of course, how many times I want to try it, and we want to know how many, the number of successes, what is the probability of having a number of successes in these n trials. And that probability of x n, which the number of successes is x and the n trials is n, of course, is going to be equal to n factorial divided by n minus x factorial times x factorial times p to the power of x times q to the power of n minus x. That is the formula to know what is the probability to have exactly x successes in n trials, when the probability is P for success and Q for failure. Voila. That's it. So easy and so simple. For this distribution, instead of doing that summation of x times p of x and so on, the mean is equal to np, and the variance is equal to npq. So you don't have to do the whole stuff. Okay. The mean is np, and the variance is npq. And of course, the standard deviation is the square root of npq. Right? Okay. Whenever I teach the binomial distribution, I give this example. Let's say that I'm going to be in a hunting trip this weekend. Okay? And all of a sudden, in the forest, I see a bear. And I have one gun, right, with 8 shots. But this bear is a huge bear, and I need to hit him 4 times in order to kill him, right? So I have 8 shots in my gun, and I need to hit the bird 4 times to kill him. Okay? If not, guys, I'm going to be dead. The bird is going to kill me. And I'm not going to be able to finish the semester. I'm sorry about that, but that's the way it is. Okay? So we have this stuff. Now, what is the probability that I hit the bird? I'm a very good shooter, but under stress, let's say that my probability that I hit the bird is going to be 0.4. Right? I mean, I'm very stressed. So 0.4 is a good probability. So I have, and how many shots do I have in my gun? 8. I have 8. And I need to hit the bird how many times? 4 times. So x is equal to 4, n is equal to 8, and p is equal to 0.4. That is the probability. Now, what is the probability that I survive? What is the probability that I hit the bird exactly 4 times? It's given by this formula. Okay? So the probability that I hit the bird 4 times out of 8 is going to be n 8 factorials divided by 4 factorials times 4 factorials times 0.4 to the power of 4 times 0.6 to the power of 4. That is the probability. So, if you want to do it, okay, what is this? Do you remember this formula over here? What is this? What is that formula?
Combination.
It's combinations. Exactly. 8. So this is 70. 0.4 to the power of 4 is equal to 0.0256, and 0.6 to the power of 4 is going to be 112.96 times 0.0256 times 17. So this probability is 0.2322, right? Is it? It is. That is correct. Now,
How did you get that?
the what?
That's 70?
70 is combination. But it's 8 factorials divided by 4 factorials times 4 factorials. That's a 70. But it's a combination. If you realize this is a combination part of the formula, this is combinations. Fortunately, we have tables. In your book, we have table. On page 839, you have the binomial probability table. Okay. On top, you're going to see the p's. On the left, you're going to see the n and the x. Okay? So, in order to do this problem, you need to find the probability which is for success is 0.4. So look for the 0.4, and you're going to start finding the probability on page 843 over here. 0.4. Okay? Not 0.04. A lot of you make that mistake. You need to find out the p. 0.4 is on page 843. But then you have to look for n is equal to 8 and x is equal to 4. Over here you have n, 2, 3, 4, 5, 7. Go to the next page, and you're going to find the 8 over here, and still the 0.4 over here. Okay? Go to the n equal to 8 and x is equal to 4, and go below the 0.4, and you're going to find the 0.2322. That's exactly what we have.
Go
Okay.
ahead again.
On page 844, you're going to see the n on the left side, and the n is equal to 8, right? And the x is equal to what? To 4. So go to the x is equal to 4, right here. Okay? And then go to wherever it says 0.4 on top. And you are going to find the 0.2322 right in here. Okay? Did you find it? Good. What if there is, if I have 0.43 as P, 0.43 is not in the table. So either you do the formula, or you can use your TI-84 as well. In the TI-84, let me tell you how to do it. In the TI-84, you have to hit the distribution that is in blue. So you have to hit second bars, okay? Second bars is right here. Okay, and you go down until you find binom PDF. That is the A. Binom PDF. Binomial probability distribution function. And remember the one that I gave you, the tips for the TI-84, TI-83 tips. Remember this sheet? I sent you in Georgia View. Okay, so that is going to give you, okay, and hit binomial and hit enter in the binomial probability distribution function, PDF. Hit enter, and the calculator is going to ask you n, then p, then x. So it's n, comma, p, comma, x. What is n? N is equal to 8, comma, then p, what is the probability? 0.4, comma, and then x is equal to 4, and hit enter, and you're going to see 0.2322432. So you can do it either the long way, the tables, or your TI-84. Okay? Now, 0.2322 is the probability that I am going to hit the bird 4 times, exactly 4 times of my shotgun. Okay? So if I have to hit the bird 4 times, what is the probability that I'm going to be here next week? Pretty small. Probably they have to send you another professor. Right? Now, that is the probability that I hit the bird exactly 4 times. But what if I want to hit the bird 4 or 5 or 6 or 7 or 8? I have to hit the bird at least 4 times. So it's 4 or 5 or 6 or 7 or the 8 times that I hit the bird. So I have to consider that. 4. This is the probability that only 4 out of the 8. Okay? So, in that case, what is the probability that x is greater or equal than 4? Okay? And that is equal to the probability of x is the 1 minus probability of x is less than 3. Less or equal than 3. Right? Remember, these are probability distribution functions, and when I add all the possibilities, it has to be what? Equal to 1. So if I add all the numbers on the table, from the 0 to the 20 or to the whatever it is, from the 0 to the 9, when I add all these numbers, it has to be equal to 1. So I want to know what is the probability of hit 4 times 0.2322 plus 41239 plus 0.0413 plus 0.0079 plus 0.0007. That is the probability that I will survive, indeed. Okay? So if you want to do it manually, you can do this on the table. It's probability that is equal, greater or equal than 4. But if you want to do it using your TI-84, your TI-84 is going to give you the probabilities that the summation of all the probabilities of x less or equal than 3. And I'm going to tell to show you how to do that. Okay? And you do that by using what? Again, second verse, go to the, instead of binomial probability distribution function, you have to go to binomial cumulative distribution function. Cumulative distribution function. This is the cumulative. And it's going to give you what is the probability that x is less or equal than a particular number, let's say 3, when you give them the rest of the process. So in this case, I want to do the cumulative distribution function, and I'm going to give you what is the value of n is equal to 8, comma, 0.4, comma, 3. Enter, and the probability is 0.5940. So the complement of this probability, 1 minus this number, is the probability that I will survive in this case. So I hit it 4 or 5 or 6 or 7 or 8. Okay? So I just wanted to show you how to do this in the TI-84 when you have cumulative. Instead of doing this every time and then adding the number. Okay?
Wouldn't the probability of surviving that minus?
Yeah, 1 minus.
1 minus?
1 minus 0.5940.
You put 4 in there, would it give you the probability that you survive?
Hmm?
You put 4 instead of 3?
Yeah, I didn't do because 4 is part of the equation. And the calculator gives you the probability that x is less or equal than a particular number. So 3 should be considered in here, but not 4. 4 is part of the 1 minus. You see? So check your tips for the TI-84 that I sent you. And you can use either the probability distribution function, PDF, or CDF. Be very careful on that. The probabilities that the calculator is giving you is, I mean, you have everything in your hands. But be very careful on how to use it. You have to use the PDF, probability distribution function, and then giving n, then p, then x. Okay, and it's everything in your cheat sheet. Okay, and the main is pretty simple and pretty easy. NP and the variance is NPQ. So basically, any questions?